here. All right, going live. Continuity. I think you guys will have an easy time with this unit for the most part because it's just a continuation of the previous one. So if you might have recalled, I kept saying, using that word, continuity. I kept saying continuous. And we just use sort of a kind of a hand wavy intuitive definition of like, oh, continuous means you can, like, if you're drawing the graph, you can keep drawing the function without picking up your pencil. Yeah. That's a pretty good definition of continuous. We'll get into a more rigorous one soon. So look at number one. Where is this graph? Where is it discontinuous? So we can keep using our intuitive definition. So anywhere where you have to pick up your pencil to keep drawing the function. So what's the first number you see? Going left to right, what's the first x value where it's discontinuous? -1. So at x equals -1, what's the next spot?
2.
2. What's the next spot? 5. No, there's one more.
3.
3. And then at 5. And then it says include the type of discontinuity. So what kind of discontinuity is there at -1? What's the name? That's called a hole. Very good. That's called a hole. At 2, that is also a hole. So there's 2. How about at 3? What's that called? Asymptote. Specifically, it's a vertical asymptote. And then at 5, what's that called? A jump.
So like on -1, why? Because there's like the dot there, but it's still just why? Yeah,
we're going to get into that. Yes, that's a great comment. Thank you for saying that. So
you're very welcome.
Yeah, -1 is interesting because there's that dot right below it. You can see on this function that f of -1 actually exists. It's equal to 1. Yeah. Whereas like f of 2 is undefined. So what's up with that? Well, it's still discontinuous at -1. So yeah. We did not make a mistake. But the next part of this question says, what's the domain of the function? Well, the domain would be all real numbers except x cannot be. Now we're going to write a list of all the x values that x is not being in this function. So is x allowed to be -1 in this function?
Yes.
Yeah, it can, because we can see that dot there, f of -1 is 1. So -1 does not make this list of excluded x values. How about 2?
Yeah.
X cannot be 2 according to this graph. How about 3?
Nope.
No.
How about 5?
Yes.
5's fine because according to this, f of 5 is 2.
So that one a jump because it has a line coming out of the other.
Yeah, it's a jump because if we want to get precise, we can talk about how at 5 there's a left limit and a right limit.
Oh, okay.
So the left limit and the right limit both exist, but the limit does not exist. That'd be a good definition of a jump. Whereas the asymptote, the limit doesn't exist. The left and right limit both don't exist. It goes to infinity. Do you feel okay about that?
Yeah.
Okay. So let's look at 2. For number 2, what are the x values at which the function is discontinuous? -2, -0, and 3. And then so the 3 discontinuities are vertical asymptote at -2, jump at 0, and there's a hole at 3. But the domain of the function.
It's different.
What x values are not in the domain of the function? -2. I've tricked you with my intonation.
It's just negative.
It's just -2. Sorry to mislead you, to deceive you. So for number 2, the only x value not in the domain is -2. So all real numbers except for -2 is the domain. It's not too bad, right? Okay, so now hopefully we have a good sense of how to do these if there is a graph given to you. So if you have a graph, you can see right on the graph where the discontinuities are. What's often more challenging is if you're given an equation.
Oh, so are we skipping through?
I'm not skipping them. You guys will have some time in class to work. You can come back and knock those out.
Okay.
Okay, so what do you do if there's some kind of equation given to you? So let's do a couple examples together. Yeah, so on number 4 here, just glancing at these, there's some that might be a jump, there's some that might be a hole, and there's some that might be an asymptote. It just depends. So 4A. Oh, it's a loud noise. Okay. Who thinks they know just in their mind? What kind of discontinuity this is going to have, if any? You think hole? Okay. Why do you think it's a hole?
I just remember when we did the whole things and you had to like cancel them.
Sure, yeah. Like I've seen it before. I've seen these before. We've done these problems before, so I just kind of recognize, okay, that's a good way to think about it. And there's going to be something canceling out. So the way this works is you go, well, you first identify, in order to be a discontinuity, there's got to be, at least for a function like this, a rational function, there's got to be some x value that's forbidden. Right. What's the forbidden x value here? -4, right? Because if you try to plug in -4, the bottom would be 0, right? Mm-hmm. So you say, okay, that's the culprit. Can we break this down in a way that gives us more information? Yes, we can. We can just factor the top. Okay. You can cancel those out, and you're left with y equals x minus 4 with a condition that x cannot be -4. So, okay. So my discontinuity is a hole when x is -4. So, algebraically speaking, what's the hallmark of a hole?
Isn't that how you find a vertical asymptote too?
Right. So that's the big question is, well, someone might go, well, wait a second. I thought if you were dividing by 0, that you have vertical asymptotes. Which is it? Well, the idea here is if you were to plug in -4 into this equation, the top would be 0 and the bottom would be 0. Okay. That is a big hint. It doesn't guarantee that it's a hole, but most of the time.
Because that's usually when we move on.
Yeah, so if you're doing a limit, this all connects with limits,
Yeah.
and, graphing. So this tells you that there might be a hole there. And the idea is if these cancel out, then that indicates to you that the graph would have a hole on it. If you want to get really precise, the real reason, if you really want to flex your wrinkly brain, okay? That's what Mimi would want. She'd want to flex the wrinkles, right? Right, Alexa? It's not just bigliness, it's also wrinkliness, okay? You'd say, well, technically, the reason it's a hole is because if I picked a number, I cannot plug -4 into this. I'm not allowed to. I'd have 0 over 0. That's an undefined quantity. It's not a number. But could I plug in -3.9999? Yeah. And if you did, you'd have -3.9999 minus 4 which is negative 7.9999. But then these two terms would divide out, and I'd be left with a y value very close to negative 8. Did I lose you with that one?
A little bit.
So what I'm saying is, I'll show you. This is a pretty important idea if you really want to understand what we're doing. Why is this a whole and not an asymptote? Well, pick a number really close to negative 4. So I'm going to pick negative 3.99. I'm going to plug that in for all my x's. So negative 3.99 minus 4 times negative 3.99 plus 4 over negative 3.99 plus 4. But wait a second. That divided by that is 1. And what I'm left with is negative 7.99. So what that tells me is that for this graph, if I pick a number very close to negative 4, the forbidden number, my y value would be awfully close to negative 8.
So how is that not a vertical asymptote?
Because for a vertical, so
It'd have to be close to it.
well, the way vertical, say if I had a vertical asymptote at negative 4, say my graph looked like this, just suppose it did, then plugging in negative 3.99 would give me a very large y. It would give me 1,000 or 1,000,000,000 or something, right?
Mm-hmm.
So that's the difference between a hole and an asymptote. For a hole, the closer you get to the forbidden number, the closer you get to what L word? Come on, what L word am I talking about? The closer you get to this, the closer you get to this. Yeah, it's a limit. So on a hole, the limit exists, right? As you approach this number, your y values approach this other number. On an asymptote, that's not the case. You approach infinity.
So how do we know if that's not a jump? Instead of just different.
Well, it's not a jump. I mean, hopefully now our graphical understanding is such that if you understand this,
It's not good.
the graph would look like
With a hole in there, yeah.
there'd be a hole at negative 4, negative 8. So we just know, it's a great question because it's not obvious that that would cause this structure, but we've studied this in a graphical context enough, okay, that we can make that inference. Put the Snapchatter away. No snappy chats. You TikToking? Okay, let's compare that to 4b. 4b. Now, it's another one. Just through recognition, you guys might know this one. We've looked at these before in the context of limits. Who knows the answer? What kind of, well, let's start simpler. What's the x value where this thing doesn't exist? Okay, so there's something happening when x is 2. Could be an asymptote, could be a hole, could be a jump. So what do we think? Who thinks they know the answer to this one? Anyone out there? Anyone at all?
Well, vertical asymptote.
Nope,
Just a jump.
it's a jump. Okay.
I don't know. Oh.
Here's why. This is thinking graphically is key here. Does this ring a bell if I start talking about if x is any number bigger than 2, what does this equal if x is any number bigger than 2?
1.
1. Do you all understand that? I can make it more concrete for you if you want. I mean, I can say, all right, so someone pick a number that's bigger than 2. 3. Sure, plug in 3. You'd have 1 divided by 1. How about plug in 17? You'd have 15 divided by 15. 1. What if I got really close to 2? If I plugged in 2.
You still have 1.
Yeah, 2.01, I'd have a penny divided by a penny. Right? I'd have 0.01 divided by 0.01, which is 1. So any number bigger than 2 will get me a y value of 1. Oh, okay. How about if x is less than 2? What if x was, we cut right to the chase and say 1.99? I'd have 0.01 over negative 0.01. My y values would all be negative 1. Is this ring a bell now?
Yes,
Please
I
say
remember
yes.
now.
That's a jump. So the answer is there is a jump at x equals 2.
Really had to look back all the way in my brain for that.
Yes. Peer into the distant past.
Wait, and so if it's just 2 open circles? Yeah, because it can't be.
Because x can't be 2. By the way, I mean, here's some food for thought. Let's say I wanted to rewrite this as a piecewise function. Is it difficult to do that?
No.
What's the rule? I'll even get started. What's the rule for if x is bigger than 2? What does y equal?
Less than negative? Oh, wait.
If x is
Negative
bigger than
1.
2, y equals 1. If x is less than 2, y equals. There you go. That's kind of neat. Pretty simple function. Piecewise function. Okay. Let's look at C. What do we think for C? What kind of stuff is going to happen on C?
Is it going to be an asymptote
Very good. Where?
at -3?
Very good. Very good. What about at 0?
Kind of not.
So for C, Aslan got the right answer. It's, as far as discontinuity. So people often will bring up 0 here. They'll say, well, what about 0? Because if x was 0, the top of my fraction would be 0. Does that cause a discontinuity?
That's for the.
It would cause a x-intercept. So you ask the question, what causes a discontinuity? Well, division by 0 is undefined. You can't do that. So you'd say, well, what x value would cause division by 0 to happen? Well, -3. Now here's the trick. You say, well, try plugging it in. What kind of form do you get? -3 over -3 plus 3 would give me -3 over 0. So if you have a non-zero number divided by 0, that indicates there is a vertical.
But you can't go any further to like simplify it.
Well,
Like if it was 0, 0, you can usually like simplify something.
well, remember a few minutes ago I was showing how like plugging in a number really close to the forbidden value causes to get like a -8 roughly.
Oh.
Watch what happens here. Let's say I plugged in. Yeah, I'm going to plug in -2.9999. Okay, really close to -3. Watch what happens. I get -2.9999 divided by, well, -2.99999. Did I say it too many times? You get the idea. -2.9999 plus 3 would be positive 0.0001. And if you divide those, you get -2,000. We'll go over 1, 2, 3, 4 spots. So you get -29,999. That's what a vertical asymptote is because plugging in, the closer you get to -3, the more gigantic your y value gets. So if I graph this, there's my vertical asymptote, -3. There's 0, 0. This would also have a final asymptote, if you're wondering, at 1, it would look something like this. So there's your enormous negative 29,999 if I plug in a number just barely to the right of -3. There you go. They're going. But guys, in practice, I mean, if you just want to like get an okay grade on the quiz, you don't care about. You're like, I just want to pass the quiz. It's very simple. If you just identify what number would make the bottom of my fraction 0, you identify it. It's -3, and if plugging in that number causes the equation to take on a non-zero number over 0, it's a vertical asymptote. If you get 0 over 0, it depends. So as we saw on 4A, a 0 over 0 form got us a hole, and on B, it got us a jump. So, all right. I think I'll spare Paige. We'll end a little early today. Gonna be okay over there? 2 thumbs up. All right, guys.